Okay, in this video what we're going to do is use Vernier to collect data for our forces lab. Your picture on your screen should look like this once we have the smart pulley attached and everything ready to go. First thing we want to do is get rid of this graph here, which is the distance graph. And we're going to click on the acceleration graph and get rid of that. And we're going to make our velocity graph here a little bit bigger so we can see a little bit more easily what's going on. And then click on the table options. We don't need the gate state, distance, or acceleration. We're just looking at how the velocity is affected in this lab. So that's ready to go. And then we want to go over, click on experiment, and we're going to go to set up sensor, show all interfaces. And the photo gate is already selected. It's already been dragged into DigSonic 1, which is where it belongs. And if I right click on that, we can make sure it's set at motion timing, which is, and then set distance or length. The smart pulleys are all 10-spoke ultra pulleys, so we'll click on that, and the default distances are fine. Then we can close out of that. And if I go ahead then and give the pulley a spin and collect data, I'm going to collect some data that basically looks like this. Okay, there's the data. I had a loose connection there, which is something you want to check too and make sure your connections are not loose. And then we should have Excel open, and I do, so we can import our data. Now if I start by left clicking and selecting this data here, we see that that's the tail end of the data I want. I would rather have a sample in the center here, so I'm going to choose that and show me where to start over here to collect my data. So I'm going to left click and drag that down and just kind of scroll that down, let it go. So I get a sufficient amount of data taken. So that should be about a sufficient amount of data. I'm going to let go on that then and hit Control C, which will copy this, and then open up Excel and hit Control V, which then copy that data into Excel. The last thing I may want to do then is go all the way down and label my axes. This would represent the time, and this other axis here, the y-axis, represents the velocity. Okay, and now we're ready to go on to the next part. We want to read through lab to make sure you know what that next part is, and that's it. I hope this helped you figure out how you're going to collect the data for your lab.